Look at this function. Look at the function f of x equals 1. If x is bigger than 0, negative 1. If x is less than 0. So this function kind of looks like that. And I want to figure out something about the limits of this function. So if I take any point that's bigger than 0, it could be anything like x equals 3, I could look at the limit of f of x as x goes to 3, and that's definitely going to be equal to 1 because the y values are staying constant. Similarly, if I take any x value less than 0, like x equals negative 2, I take the limit as x goes to negative 2, and those y values, they're staying constant. So that limit would be equal to negative 1. That's no problem, but something more interesting happens here. What about the limit? So x goes to 0 of f of x. And so our intuition for this is saying that this limit's going to be equal to something if it's true that whenever the x values are close to 0, the y values are close to a single number. But here's the problem. You can be really close to 0 and positive, like x equals 0.01, and here your y value is equal to 1. You could be really close to 0 and negative, x equals maybe negative 0.01, and here your y value jumps down to negative 1. So since it's possible for the x values to be really close to 0, but to have two very different y values, we say that this limit does not exist. So there's your simplest example of a limit that doesn't exist. That's really different than that sine x over x, because then you could kind of fill in the gap. But here you can't fill in the gap to really complete it.